looked at solving, actually, I'll pull it up for you. We looked at solving systems of equations by graphing. Okay, we looked at the different types of systems. A system is just when there's two or more equations together. And when we're looking for a solution, what we're looking for is the point that they intersect. Okay, so you'll either have a system that intersects at one point, and that point is your solution, or you'll have parallel lines, which means there's no solution, or you'll have two that are identical. They end up being the exact same line, the same equation, and there's infinitely many solutions. Okay, so those are the three possibilities when graphing of what they could look like. So what we're going to look at today is an alternate method for solving systems, and it's called substitution. Okay, so in this method, okay, graphically is a visual way. Okay, however, there are times when the intersection point is not always clear. Okay, especially for a case when the solution has a fraction. We can solve it algebraically. Okay, and again, this is called substitution. I'm going to fill in that first blank there. All right, so substitution is exactly what it sounds like. Okay, so for instance, when I'm not here or one of your teachers isn't here, there's a substitute. Okay, there's somebody in our place. Okay, substituting things like when you do an online grocery order, I don't know if you've done it or your parents, but if they're out of something, they may substitute it with something else, like a slightly different brand or a different size of the item. Okay, but a substitute is like replacement for something. So with equations, if you have one of your equations solved for a single variable, okay, that's always step one here, okay, solve for a single variable. So the two equations that are given to us here, that's already done. We already have y equals. So y is by itself in one of the equations. It can be x or y, it doesn't matter. In this case, it is y. So we have y equals 2x already. Okay, so what we're going to do with that is we are going to substitute it into the other equation, okay, and solve. So in the other equation, there's where y is, okay? So I'm going to have x plus y equals 4. Now I am going to substitute instead of y, we said y is 2x. So I'm going to replace the y with 2x. Okay, so I make that substitution. Okay. Now I'm going to solve. The only variable left here now is x's. So I've got 1x plus 2x. So what does that give me? I have 3x now. So I combine like terms here. That's 3x equals 4. Okay, now if I'm trying, gentlemen, please stop talking. If I'm trying to solve for x, how do I get rid of that 3? That 3 is being multiplied by x. So what's the opposite operation? Nobody knows the opposite of multiply. Thank you. Divide. So we're going to divide the 3 to the other side. So that gives us x equals, and we're just going to leave it as a fraction, 4/3. That is a repeating decimal, so we don't want to have to round or anything. We want to just leave it as the exact answer. Okay, so we've got x is 4/3, so that's one of our variables. But now we need to go and find the other variable, the other value. Okay, so now that I know what x is, I want to know what y is. So I'm going to go back to that equation I started with because I want to know what y is. So I'm substituting 4/3 in for x. And actually, I'm going to color code that. I write that in red. Yes. Okay. So we said x was 4/3, so you can see I'm replacing the x or substituting the x with 4/3. I'm going to solve for y. So 2 times 4/3, when you multiply a integer by a fraction, you just multiply the top. So 2 times 4 is 8. So that is 8/3. So I've got x, I've got y. Now I need to do the final step, which is to write the solution. We said yesterday, your solution is an ordered pair. It's a point. So if you need to write a reminder here, a solution is going to be written in this format, like an ordered pair. Okay, so my solution will be 4/3, comma, 8/3. That is my solution. That is the point. If I were to graph these, that is the point where they would intersect. So I actually did 2 substitutions. I did the original substitution for y, and then I did this substitution for x. So far, so good? All right, well, in the second one, neither of these equations is solved for a single variable yet. Okay, so I actually have to do a little bit of work in this first column. Okay, it's not just given to me already solved for one of the variables, like in number 1. Okay, so I can solve for x in the second one, or I can solve for y in the first one. It doesn't matter. Okay, so I'll let y'all pick. Do y'all want to solve for y in the first equation or solve for x in the second equation? And the reason those are my 2 choices is because that's y is got no coefficient here. This x has got no coefficient here. So those are the easiest ones to solve for. We don't want to solve for x here or solve for y here. That's more work. Okay, so we want to solve for one that doesn't have a coefficient already. I guess let's just use the first equation to keep it simple. So here's the first equation given to us, and we are going to solve for a single variable. That's y here. I want to get y by itself. Okay, so to get y by itself here, I have to move this 2x to the other side. So I'm going to subtract 2x. What I do to one side, I do to the other. Now, I've got y by itself. I cannot combine 11 and minus 2x. This has an x, this does not. So they don't go together. I keep them separate. So you can write it as 11 minus 2x, or you can put it in slope-intercept form and have the x first. That's fine too. Okay, so I've got one of my equations solved for a single variable. So now I'm ready to substitute. Y is this expression. So in my other equation, so the second equation, I am going to substitute for y. So I'm replacing the y with negative 2x plus 11. Because that's what y is equivalent to. That's what we said y equals. So I substitute it. So now I need to solve. Okay, so that 2 was being multiplied by the y. So this 2 has to be multiplied by this expression. So I have to distribute it here. So the x is still out here in front. That's not changed. But then a 2 times negative 2x would be negative 4x. And then 2 times 11 would be positive 22. And then I've still got equals 18. Okay, so I'm going to continue solving this. I'm going to combine like terms here. Got x minus 4x. So that is negative 3x. I've still got plus 22 equals 18. So now I'm going to move the 22 to the other side by subtracting. So I'm left with negative 3x. Now over here, I can combine the 18 and the 22 because neither one has a variable. Those are both constants. So I get negative 4. And then I've got to get rid of that negative 3 that's being multiplied by x. So I'm going to divide. Now a negative divided by a negative comes out positive. So this is positive 4/3. Okay, so I found x. I found one of my variables. So now I'm going to go back to that equation right here, this equation where I had solved for y. And I'm going to substitute in x. So instead of x, I'm going to put 4/3. So this is my second substitution step. Because x is 4/3, I can make that substitution. So now I'm going to solve for y. So when I multiply that, that's negative 8/3 plus 11. Okay, well, when you're adding fractions, you want a common denominator. So instead of 11, we can rewrite 11. If we want it to be thirds, we have to multiply by 3. So 11 times 3 is 33. So I'm going to replace 11 with 33/3. So now I can add those because they have a common denominator. They're both thirds. So I've got positive 33 and negative 8. So you're just doing 33 minus 8, which is 25. And it's all still over 3. So we've got x, we've got y. Now we need to write it as a solution, as an ordered pair. So 4/3, 25/3. Okay. Let's flip it over and I'll try another one. Okay, if you look at all of your x's and y's here, the only one that doesn't have a coefficient in front of it is this y in the first equation. So that's the one I'm going to solve for first. So I'm going to take that first equation and I'm going to solve for y. Now there's two ways you could do this. You could subtract the 2x over, and then you would have to divide the negative over. Or you could add the y over and subtract the 1 over to like switch the sides that they're on. And I actually think that one is a little easier. You don't have to worry about dividing by anything. So I'm going to add the y to the other side so it's positive. And then I'm going to subtract the 1 to the other side. So then y is all by itself. And this is 2x minus 1. Okay, so the first substitution I'm going to do is going to be for y. I'm going to replace it with 2x minus 1 in the other equation. Okay, so that second equation is 5x plus 3y equals 0. And I'm going to substitute in for the y 2x minus 1. So I'm replacing the y with 2x minus 1. Now to solve, I'm going to do the same thing we did on the last one. I'm going to distribute this 3 that's up against the parenthesis because that 3 is being multiplied by this. So 3 times 2x is going to be a positive 6x, and the 3 times negative 1 is going to be negative 3. Now I've still got the 5x in front. That didn't go anywhere, and it's still equal to 0. Okay, so now I'm going to try to solve for x here. So I'm going to combine like terms. 5x plus 6x would be 11x. We've got the minus 3 equals 0. So then I'm going to add 3 to the other side to get eliminated on the left. So I'm left with 11x equals 3. And then I'm going to divide out the 11. So x is 3 over 11. So now that's going to be the second thing that I substitute. Now that I know x, I'm going to take it. I'm going to go back to this original equation I came up with in step 1 right here. I write it down again, 2x minus 1 equals y. And I'm going to replace the x with 3/11. So I replaced the x with 3/11. So when I multiply that, that is 6/11 minus 1. Now, I'm going to get a common denominator like I did on the last one. If I want my denominator to be 11, I'm multiplying by 11. So 1 times 11 is 11. So I'm replacing the 1 with 11 over 11. That's the same thing. 11 divided by 11 is 1. Okay, but now I have a common denominator. So 6 minus 11 be negative 5/11. I got the y, I've got the x, so now I'm ready to write the solution. 3/11 negative 5/11. If I were to graph these two lines, this is the point where they would intersect, which would be hard to tell on a graph since it's a fractional value or decimal value. If you preferred to have it as decimals, you can, but again, this is another kind of repeating decimal, so it's not very pretty. All right, let's try one last one. Oh, no, that was it. That was the one last one. Okay. So this is the substitution process. Okay. So I organized it into the columns like this so you could go step by step and repeat these steps for the practice problems. Okay, so in the practice assignment, let me pull it up here. I will tell you which problems we're going to do. You can make sure you Don't do more than you need to. All right, so I'll pass this out, but let me circle on here what you're going to do. You're going to do 2, 3, and 6 on the front. And then on the back, you're going to do, hang on, I have it written down here. Let me double check. Yeah. You're going to do 7, 10, 11, and 14. Okay, so I'll pass this out and you can circle those problems and only do those. So you're only doing half of the actual paper.